You know, I know how much you all love listening to these. I mean, that's what Chelsea was telling me the other night, that she just listens to them every night over and no. It's good, right. Helps you fall asleep. It's excellent, Nick. That's exactly what I'm trying to get for you here. Okay. What did I do? There's my remote. Okay. So let's, I also have to remember not to talk so loud. I'm used to talking loud, but it doesn't work on this. Okay. Reviewing for you. To remember where we were when we left off yesterday. We're talking about these tissues, right? 4 main types of tissues: epithelial, connective, muscle, and nerve. And so far, all we've talked about is epithelial, and not even all of the epithelial, just a couple of them. We talked about simple squamous. Y'all don't like it? Something, right, I didn't say anything, did I? Oh. Squamous, okay, yeah. So yeah, simple meaning what, friends? Single layer, one layer, and squamous meaning? Not square, though it kind of looks like it. Not cubed, not kind of, and scales. Yeah, that's what I always make me think of, scales. Like snake skin, right? Doesn't this bottom picture here kind of look like snake skin, that view? Okay. So simple squamous. Then we had simple cuboidal, and that was simple meaning one layer, cuboidal meaning cubes, right? These cube shapes. As a reminder, you do need to know where they're located, right? So where is this simple squamous located at? Lining of the alveolar sacs, right? The lungs, more specific, alveoli sacs. That's the actual part of the lung that you breathe with, right? You have a question?
Yeah.
Please.
In the picture,
yes.
Bottom right.
Okay.
So
over here.
Lines, are they cell walls?
They are.
So
Yep.
why is there like 3, sometimes like 4 nuclei in one cell?
Sometimes 4. I'm assuming that those are like actually from another cell that they're picking up the stain there. You can see when they draw them, they drew them with only a single one. I wouldn't think that they would have actually multiple nuclei. It could theoretically, this was 2 different layers of this squamous that was on top of each other. Yeah, theoretically. Yeah. Shh. Because again, the pictures on the left are trying to tell you about the pictures of the right. It's like a diagram of the actual pictures, the actual microscopic pictures. Okay. Moving on. Simple cuboidal, where are those found at? Kidneys. Sure, in particular the tubules, like the actual part of the kidney that's doing the filtering. Okay? Simple columnar, simple meaning again, one layer. Columnar meaning, yeah, columns, rectangular, right? And you can see their nuclei are nice and lined up, nice and pretty. You have these big circular blob-looking things that are called the goblet cells. It kind of looks like a goblet right here, doesn't it? Like here's the top where the drink is, and here's the stand. Kind of, maybe visualize. If you squint your eyes a little, no, maybe not. Yeah, turn your head and wink. No, doesn't work. So goblet cells, and the goblet cells produce what, friends? Mucus. Good, good, good. Where are they found? Small intestine, the lining of the small intestine. Innermost, good. Yeah, got it. And I'm pointing you out here again, this microvilli. And again, the point of that microvilli is to give you, well, no, this is not moving. Microvilli is not for moving. That's cilia. Increase the surface area. More area to absorb, right? More area to absorb nutrients. Because, right, of course, that's the whole purpose behind the small intestine, is absorbing nutrients. Okay, so knowing the goblet cells, knowing the microvilli. And that's where we finished off, right, friends? Good. Let's keep going then. Oh, no, we did talk about pseudostratified, didn't we? Briefly. Briefly. Okay. Right. So pseudostratified, pseudo meaning false. Stratified means more than one, right? More layers. They're striated. They're on top of each other. They make lines. So pseudostratified means it looks like it's more than one layer, but actually it's only one. And you can see how these nuclei kind of go up and then down, instead of the nice, pretty row for simple columnar. Goblet cells also present in this pseudostratified columnar, but then you also have the pieces on top. Instead of microvilli, you have cilia. Okay? And now the cilia is what helps movement, moving that mucus up and down. Because these guys line the lungs, the bronchial tubes, as a matter of fact, which are basically the path from your mouth to the lungs, to the actual alveoli sacs. Questions there? Good. So now you get to what I call your typical stratified epithelium. This is stratified squamous epithelium. Okay? So they are showing you as this being the lining to your esophagus. The esophagus, of course, is the tube from your mouth to where?
Your stomach.
Well, okay, your intestines by way of the stomach. Okay? You have two tubes. I'm sure you realize this. Two tubes that both have their entry point in your mouth. One that goes to your lungs, one that goes to your stomach. Of course, the main goal is to make sure you don't let the things going to your lungs go into your stomach. If you do, that becomes a belch, right? You have air in your stomach, you have to get rid of that, right? That's what a belch is. If you get fluid or food that is supposed to go into the esophagus, into your lungs, what do we call that? Choking. Yeah, so that's why you cough and because your lungs can't handle that. If you end up with fluid in the lungs, or even food, frankly, you can get food in your lungs. You can get infections. You can die. That's what pneumonia is. Pneumonia is fluid buildup in your lungs. So, I lost you when we talked about choking, so come back to me, friends. Shh. Yes, ma'am.
So why do people say that if you go outside and it's cold without your hat, then you get pneumonia?
Well, you can get sick. Yes.
But it's not.
I mean,
It's not actually.
yeah. And it's not actually true that you can't. Yes. But oftentimes it will. But there's not a direct relationship between temperature and getting sick.
Yeah.
So, okay. You can see very obviously, right, that these are multiple layers of cells. In truthful honesty, the only ones of these cells that are actually living are probably about these guys. Below that line. All of these other cells are basically dead cells.
Is that your skin?
Sure, skin responds very similarly to this. Okay, same kind of cells. Okay? So really what you see on the outside, this is dead. This is totally dead. And they do that, why? Why do we want this big, huge layers of cells? It's all about protection. That's exactly right. Okay? Think about this. They're showing you this tissue as being the lining of your esophagus. Think about all the stuff we eat, right? That has to travel down this tube into our stomach, right? You want that to be pretty tough tissue, right? Pretty rugged, pretty strong, you know? It's totally gross, but this point was made to me very clearly when I was in PT school by one of my instructors. You comfortable? The whole point of this chapter is that different tissues are for different places and have different functions, right? Your eye tissue, right? That make up your eye. You're comfortable how sensitive that is, right? How we don't, I mean, our body has developed significant protections to keep us from hurting our eyes, right? Involuntary blinkings, you know, you shudder, you close. Very protective of that very delicate tissue. You with me? What my professor said was, imagine that that tissue was the same tissue that lined the inside of your rectum. You know, when you have a bowel movement, the tissue that waste moves past. Imagine that was as sensitive as your eye. That same thinness of tissue. That would be extremely painful, right? So that for whatever reason stuck in my mind like, oh wow, okay. Different tissues do different things. And you want them to be different layers, right? This would be like your very strong, very thick tissue, right? This stratified squamous epithelium. Question?
Sorry,
Shh.
off topic. I'm not trying. How exactly do warts happen?
I am not 100% sure. I know that they are, I think, some sort of bacteria or viral growth there. Or maybe a fungus. That's actually probably what you're correct. That's about all I know, to be honest. Other questions about stratified squamous? And again, remember all three names. Stratified, multiple layers. Squamous, meaning the scale-like epithelium type of tissue. Next, you get stratified cuboidal epithelium. I really dislike this picture on the left here because there are many places where there's only one layer, right? And so it's kind of hard to tell that it's a stratified. But this is much clearer. You see that there are multiple nuclei on top of each other in most of the places around here. So this is stratified cuboidal epithelium. Where is this located? In your mouth, sure. More specific, though. Say it again. Salivary glands. So these are the glands that produce the saliva in your mouth. Right? Everybody did this. There's some saliva there, yes. Okay? It's good. So that is stratified cuboidal epithelium. Moving down. Next, you get stratified columnar epithelium. So we can see that these are the columns that are stacked on top of each other. This is not very zoomed in. Much, much more big picture. And where is this located? What tissue is this stratified columnar? It is a part of that, but go more details. In the urethra, the lining of the urethra, which is not just a male reproductive system, by the way. Females have urethras as well. Okay? They don't have the same external appendages, but this is the urethra is the tube from your bladder to the outside. Good. Keeping that same systems, you get to transitional epithelium. And this is pretty cool stuff. Take a look at this top picture versus the bottom picture. What's happened there? Like what difference do you see? Say that again. Which is squished? Okay, it's actually the opposite of squished. Like we've taken it and we've stretched it. Does that make sense? Oh, you were thinking this direction. She was thinking up and down. Okay. No, as far as side to side. This transitional epithelium actually has some elasticity to it. It actually will stretch. Where is that transitional epithelium located at? The urinary bladder. Now, why would this be a good thing to have a bladder that will stretch?
Because when you have more liquid,
Holds more urine, right? That's exactly right. When it reaches this certain amount of stretch, that's what triggers the thought to your brain that, oh, I need to go use the bathroom. Because your bladder is continually filling with urine. No, you can't go to the bathroom. Sorry. No, I'm just
Like when you're peeing.
It's good.
You know how it stretches out. Okay, so like when you're peeing, is it like putting it back together? Is that what the pressure is shooting out?
That's good. No, that's a good
Fill
thought.
it up with water.
And you squeeze and right.
And a little bit of water's left over, right?
That's good. I suppose that there is. It's a great question. I've never thought of the question before. I think that more of the force comes from those internal muscles actually kind of squeezing the bladder rather than just the bladder itself, the pressure. But I would imagine a little bit of that. Let's say you were comatose. Let's say you weren't awake at all. You were in a coma. You still go to the bathroom. I would imagine it would be just that pressure from the... Yeah.
So that's why like connected to like your hands, like
Sure. You know, they just can't control it. That's what we spend the first number of years of our lives trying to figure out how to do that. Yeah. Shh. If you're in a coma, they would probably give you a catheter, which basically is a tube they insert up the urethra into the bladder, and it just drains. As the bladder fills, it drains out. Yeah. As far as bowel movements go, I mean, you can have that. Again, that's not. You don't need a conscious thought to do that. It can still happen. Yeah. Because then the body is still having to live, right? The kidneys are still filtering your blood. That's what your urine is, right? Your stomach is still breaking down, and your intestines are breaking down the foods you're eating. So yeah, even in a coma, you're still producing wastes. Good. They would just put fluids or things into you. Yeah, they would keep you. Okay, friends. Shh. Get you talking about wastes. It's good. We said we had a joke for many years in A&P class. Everything always came back to poop. Always, like every class came back to that in some way. And if it wasn't poop, it was sex. One of the two. So it's all right. We don't mind. Okay. Shh. This diagram here, shh. This picture's got a number of different pieces to it, so I'm going to spend a little bit of time here. Where are we at here in your textbook? What page is this? 101. Page 101. Okay. All right. So you have three different kinds of these glands. Okay. First of all, what is a gland? What does a gland do? Gives off things, right? Produces something. It can be a hormone. It can be an oil. There's a million different kinds of things that we produce, our bodies produce. So there are three specific types. And here are the names: merocrine, apocrine, and holocrine. Okay? So let's look at them. Merocrine, the cell secretes whatever it is it's making. Let's say this is a hormone. Okay? It gives off this lovely green hormone, but the cell is not affected. You see this here? It's an intact cell. The cell is not changed in any way. Okay? That is the merocrine. We cool? And I always think of marrow, I think of like merit, like that's the good way of doing it. I'm not affected, I produce this and I'm unchanged. I have a lot of merit. That's how I remember it. Next we have apocrine, which is here. Apocrine, you can see that instead of it just secreting this stuff, just pushing it out of the cell, this exocytosis, right? Instead of just simple exocytosis, it's actually pinching off a part of it, and that part of the cell contains that secretion. Are you with me? So it's like literally, if I want to give you something, I'm going to break off my arm and give it to you. Does that make sense? So an apocrine, I think about an ape like pinching a banana and eating it. An apocrine, right? I'm just telling you that's how I associate things in my mind. Okay? So this guy, for merocrine, intact cells. For apocrine, pinched off, a little piece of it comes off with the secretion. And then holocrine is where the cell literally has to die in order for the secretion to come out. Have you heard of this term Holocaust? Right? Killings of multiple thousands of people, right? Okay? So holocaust meaning death, the death of this cell. Holocrin, the death of this gland. Okay? These make lovely multiple choice questions, right? Which gland is it that the secretion requires the cell to pinch off a piece of it? Or I wouldn't say pinch off, because of course you would know that immediately. But to break off a piece of it, and you would say apocrine, right? Which type of gland is the cell unaffected in production of its secretion? Merocrine. Which type of gland does the cell undergo complete lysis? Oh, we're going to use good medical terms here, right? That would be holocrine. Lysis meaning to die, right? To cut, to kill. Good. Are you with me, friends? They're showing you in the picture here that these are actually the sebaceous glands, the oil glands in your skin is an example of these type of glands. Yes, sir?
Marianne, I have a question. How does the apocrine gland relate to this picture?
How does the apocrine, that's the spleen.
No.
Oops, that's merocrine. I apologize. This is the mammary glands.
Yeah,
Well, right. No, so the actual mammary glands is what produces the milk. Yes. So saying that secretion, that milk actually contains part of the mother's cells as well. Yes. Yes. Well, but it's not necessarily a bad thing. You know, we get a lot of very good things from our mothers in that milk. But does it contain little bits of them? Sure, it does. It does. Right? Yes. 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 Are you with me, my friends? So again, the spleen is a merocrine gland, where it's just simply producing the things that it produces, the different hormones. Apocrine gland is the mammary glands, producing that milk. And holocrine is the sebaceous glands, the oil glands of your skin.
Does that apply to cow's milk too?
It's a great question. Probably. Good, we're going to keep rolling, friends. Shh. There is a lovely chart that is there, table 5.3. Can you tell me where that is in your textbook? Page 102. Here is kind of all the cells we've just done, all the tissues, we've just done, all in one nice place. Here's the names. They give you some functions and then telling you locations. So if you want it not just visually, but you want it written, it's a nice place to go. On page 102, you said?
103.
103. 102. It keeps changing. Okay. So we've covered epithelial tissues. Now we're going to cover connective tissues. There's a good amount. This is a fibroblast. By the way, this is a very zoomed in picture. What is your textbook says this is 4,000 times zoomed in? Yes, quite small. What does a fibroblast do? We are on page 102. Produces fibers. Fibroblast. To blast, I think of like this cell shooting them out with a big bazooka. I'm blasting out the fibers, right? I'm producing these fibers. In bones, the cells that actually create the bone tissue are called osteoblasts. They blast out the osteos, the bones, okay? So fibroblasts are producing this fibrous tissue, these fibers that are really all over the connective tissue of your body.
What's extracellular matrix?
Extracellular matrix, that's kind of the in-between the cells kind of stuff. There's a great piece that's here on page 104 and 105 about extracellular matrix. So take a peek. I'm going to point you there. and let you do some reading there.
Yeah, it comes out protein.
Mm-hmm. The fibroblasts, you're saying?
Yeah.
Yes. Good. Okay, moving on to the next little piece. What are these guys here? Are you with me, friends? Have I lost you? So these are the mast cells. Shh. Mast cells release heparin and histamine. Have you heard of histamine before? You heard of antihistamines. What do we use antihistamines for?
Allergies.
Allergies, right? So histamine is your body's response to an allergen, to something that it doesn't like, that it doesn't recognize and wants to get rid of. The mast cells are what produce that. Antihistamines would shut down the production of these mast cells, production of the heparin, or the histamine.
Wouldn't that be bad though? Because then you're not fighting off.
Sure, in some ways it's true,
Right?
but more we're talking about abnormally high responses to something that's not life-threatening. Like, for example, I'm allergic to cats.
Oh, okay.
And the cat is not going to kill me, right? But my body responds by, I get a hard time breathing, my eyes water, my nose gets real stuffy.
So your reactions are more dangerous.
Right. So we're trying to limit those. And they're also very uncomfortable. I don't like them. Yes? Shh. It's like the dander, the cat hair and dander. And I get them skinned already, so I don't have to worry about that. Yeah, no, it's a great question. Great question.
They don't have skin. Or
I should say that the fur is taken off. Yeah. It's a real pain in the butt otherwise. Yeah. It's a real pain in the butt. Okay, next one. Shh. Oh, sorry, no, I forgot one more thing. Histamine. We talked about histamine. Mast cells produce two things, histamine and heparin. And what does heparin do? Prevents blood clotting. You want an amazingly complex system. They do. Which is right. Definitely. Keeps it from clotting. If you want to just kind of think about an amazing thing for a minute here. Are you comfortable that if I went and sliced my hand right now, I would bleed? I would bleed my own blood all over here, right? It's a good one, right? So, yes. But as soon as I started bleeding, are you comfortable that my body would try and clot, right? That blood would try and clot to stop the bleeding, right? As soon as possible, right? My question is, or what I want you to think about is, why doesn't your blood just clot all the time? You realize, hang on, stay with me. Don't try to answer. Just think about it for a minute. You realize that that is what a stroke is most of the time. Your blood has clotted. There's been a clot that's formed in the brain that blocks one of the arteries going to the brain tissue, and the brain tissue dies.
does that mean you get a scab inside of you?
It's not actually a scab. It's just a clot that forms there. Okay? Think about this. An embolism, a pulmonary embolism, is basically a blood clot in the lungs. You can die from this. Okay? A heart attack is a blood clot usually, or some sort of clot. It can be the plaques that are building up in the arteries. But it's clotted in your heart vessels there, and you die, right? So in all these cases, blood clotting kills you. But when I slice my hand, I prefer that it clots quickly, right? You see that huge and that is a big dichotomy. These guys are anxious to put their hands up. Yes, ma'am.
One question, but
Okay.
okay, I know the blood goes through our veins, but like you cut yourself, how does it? I don't know, because if you're not cutting your vein, then you still bleed.
Well, all the tissue, like all of the capillaries, all the everything in your whole entire body gets blood flow to it. It couldn't live without it. So even though I may not cut an actual big dark vein, there's still plenty of blood flow that gets to those tissues that I am damaging. Does that make sense? If I cut deep enough and I can cut then one of those nice, big, thick, yeah, sure, you'll bleed a lot. Yeah. Okay. Yes, did I answer the question or you had the same one?
Yes.
Okay. Oh, I'm sorry. Good.
Well, I was thinking, does like blood clot when it reacts to oxygen?
It does. That is one of the big, when it responds to the air that's present there. And it's truthfully this whole big cascade. It's an extremely complex process. There's a fantastic book called Darwin's Black Box, written by Michael Behe is the name of the guy. He wrote this about 15, 20 years ago now. He calls that system irreducibly complex. There's this whole series of reactions that have to happen for blood to clot. If I took out one of those reactions, it would stop clotting. And his proof of that is that's showing you that there's an intelligent designer, that somebody had to design this process. It couldn't just come together all by itself. It's a fascinating book. Check it out. I would recommend to you. Okay? Last one I'm going to cover for today are these mast cells. What does the mast cell do? Mast cells? Oops. That's what we were just doing, didn't we?
Yeah.
Mr. Haas. I was meaning to show you that this was a macrophage, not a mast cell. This is a mast cell. Shh. The macrophage is something that carries on phagocytosis. Well,
Oh, right.
phagocytosis means to eat, right? So this macrophage is coming and eating this other bad cell, right? They function as a scavenger and defensive cells that clear foreign particles from tissues. Like the trash collector, right? Except the trash man eats all the trash. Kind of strange, but true. Okay. Good, that's what we're going to end for today, and we will continue with connective tissue further tomorrow.